Hello all, this is Trusha Patel. Welcome to the part 3 of macroprocessors. Let us talk about macros in assembly language. So in macro definition, a macro definition is enclosed between the two statements, that is macro header and macro end statement. Typically macro is located at the beginning of the program. The syntax for macro definition is something like this. The first is macro, that is the macro header statement. Last is amend, that is macro end statement. Inside that, the first statement is macro prototype statement, which consisting of the macro name and the formal parameter space. Formal parameter is having two things, the parameter name and parameter kind. After the macro prototype statement, there will be so many statements and they are called the macro body or the model statements. Next is macro call. A macro is called by writing the macro name in the mnemonic field of the assembly statement. The syntax of macro call is macro name followed by the actual parameters. Next is macro expansion. During the macro expansion, the macro call is replaced by sequence of model statements of the macro body. To differentiate between original statement of a program and statement resulting due to the macro expansion, each expanded statement is marked with plus sign at the beginning of the statement. Let's say for example, this is our program. We have one macro definition and one macro call. Inside the macro definition, we have macro header, then macro prototype statement, body of the macro, and macro end. These three are the formal parameters in the macro, and these three are the actual parameters in your macro call. After the expansion, this three body statement of the macro will be added in place of the macro call, and as you can see that all three statements are marked with plus sign at the beginning. Now there are two types of macro expansion. First is lexical expansion, second is the semantic expansion. In lexical expansion, after the expansion of the macro, the resultant code will remain same for every time. While in semantic expansion, the resultant code may differ in number of line or the sequence of code or the set of the instruction depending on the different use of the macro. During the macro expansion, two things we have to focus on. First is expansion time control flow and second is lexical substitution. Now, expansion time control flow, it determines the order in which the model statement are visited during the macro expansion. The default flow of control during the macro expansion is sequential. A preprocessor statement can alter the flow of control during expansion such that model statements are either never visited during the expansion or repeatedly visited during the expansion. The flow of control during expansion is implemented using a macro expansion counter, that is MEC. Have a look of the algorithm. MEC is initiated with the statement number of the first statement following the prototype statement. While the statement pointing by the MEC is not a macro end statement, it will check that is that statement is a model statement. If yes, it expand this statement and MEC will be incremented by 1. Otherwise, it will be a preprocessor statement. In that case, MEC will be assigned a new value which is specified by the preprocessor statement. And this will continue at the end when your MEC is pointing to the ME end, that is the macro end statement, the macro expansion will be stopped. Next is lexical substitution. Lexical substitution is used to generate an assembly statement from the model statement of macro body. A model statement consisting of three types of string. First is an ordinary string, second a name of a formal parameter, third a name of a preprocessor variable. During lexical expansion, string of type 1 are retained without substitution and string of type 2 and type 3 are replaced by the value of the formal parameter or preprocessor variable. Now there are different kind of parameters are available. First is the positional parameter, second is keyword parameter, and third is default parameter. Let us have a look on all of them. First is positional parameter. A formal parameter is written like n% then the parameter name. An actual parameter is written as just a parameter name. For example, incr macro name followed by n%x, n%y, n%reg. So these three are your formal parameter, and in macro call you have the actual parameter, that is a, b and areg. So A is mapped to X, B is mapped to Y, AREG is mapped to REG. So here in the positional parameter, the position of the formal parameter and actual parameters are mapped. So first actual parameter is mapped with the first formal parameter likewise. Second is a keyword parameter. The formal parameter is written as n% parameter name equals to. An actual parameter is written as a pair formal parameter equals to the actual parameter. In the example, in incr macro, n%x equals to n%y equals to n%reg equals to. These three are the formal parameter. You can see in the macro call, the sequence of the parameters are changed. Reg equals to areg, x equals to y, y equals to b. So areg is mapped to reg. This is placed in the first position in the actual parameter, while reg is available in the third position in the formal parameter. So sequence doesn't matter over here, but every time we have to write down formal parameter equals to the actual parameter pair in the macro call. Now, next is the default parameter. Default is a standard assumption in the absence of an explicit specification for the parameter. A formal parameter is written as a pair n% parameter name equals to default value. Now here in example, in a macro call, we have written y is equals to b, x is equals to a. So b is mapped to y, a is mapped to x, but for reg we haven't written anything. So reg is assigned a default value, that is areg. But in a second example, if we explicitly mention that reg is equals to breg, so instead of taking the default value, it will map breg to reg argument. The next is the mixture of the parameter. You can see in the example the parameters I have highlighted with the blue color, that is the positional parameter. Parameter highlighted with the green color, that is your keyword parameter, and gray color, that is your default parameter. Now next is the nested macro call in the assembly language. Here we have a two macro. First is incr and second is computer. Now if we have a call for computer x comma y, now here x and y are the actual parameter, and in computer we have n% first, n% second. These two are the formal parameter, that to the positional parameter. So x is mapped to first and y will map to second, and the first expansion will be something like this. That are the three body statement of your computer macro. Now inside that we have a call of incr. So because of that, the next expansion will take place and incr will be replaced with the body of the incr macro. Now processing the nested macro, there are two possibilities. Possibility number one, Let's say in my source program, I am having the call for the macro number 2, and inside the definition of macro 2, I have a call for the macro 1. So in the first expansion, both the M2 call will be replaced with the body of M2, and in the second expansion, the call of M1 will be replaced with the body of M1. The second possibility is the first M2 call is replaced with the body. Inside that we have a call for M1 that is again going to be replaced with the body of M1. Then it will start expanding the second call of the M2, and after that inside it is having M1 call, so it will expand the M1 again. Thank you for the part 3. We'll be back with the part 4 soon.